Hi everybody, it's Leanne here. I'm going to talk through class activity N instead of just giving you like the solution sheet, which is sometimes a little bit hard to interpret. So hopefully this will help. My sheets have this big copyright thing on them, so please ignore that watermark. All right, so this is the only class activity you're doing this week. It's basically looking at can we use a proportion or not. And a big misconception that happens when students learn to use a proportion is if they don't have the solid fundamental reasoning behind why we would use it, then they try to use it for everything. And so that's really where this is coming from, this class activity, getting you thinking about whether or not you can use a proportion. All right, so Ken uses 3 loads of stone pavers to make a 10 by 10 foot square patio. I'm gonna actually get a pen going here. So I always like to kind of draw what I'm thinking about here. So that 10 by 10 patio took 3 loads of stone pavers, and he wants to make another square patio, but this one 20 by 20, right? So he wants to make, ooh, well, that's weird. Okay, he wants to make this, right? 20 by 20. So is this proportion? Can he just do 3 loads per 10 feet equals X loads per 20 feet? Well, he can't, because this is an area problem, and you probably intuitively knew that when you read it as well. Remember, the new patio is going to be 4 times, not 2 times as large, but 4 times as large. And by me drawing this, maybe you can see how the patio is going to be 4 times as large, because we doubled this side and we doubled this side. And so our area is quadrupled, not doubled. So actually he's going to need, so since the area is going to quadruple, he's going to need 4 times the 3 loads, or he's going to need 12 loads for if he wants to make a 20 by 20 patio. All right, in a cookie factory, 4 assembly lines make enough boxes of cookies to fill a truck in 10 hours. So how long will it take to fill the truck if 8 assembly lines are used? And is this proportion appropriate for this situation? Why or why not? Okay, so we're going to assume that all assembly lines work at the same steady rate. More lines will not require more time, but actually less time, right? So he should take it should take half as long, or 5 hours. So just reasoning through this problem is the better approach rather than setting up a proportion, which in this case isn't the appropriate way that we would go about solving this. All right, number 3. In the cookie factory of part 2, how long will it take to fill a truck if 6 assembly lines are used?
Abby Hampton, if you're in the building, please come to the office. Abby Hampton, please come to the office.
So I'm looking down here. I know 1 line takes 40 hours. So 2 lines will take 20 hours. So we have to reason through this by making sense of the fact that it's going to take less time the more lines that we have. So 4 lines take 10 hours, 8 lines take 5 hours, 16 lines will take half of that, or 2.5, and then 32 lines will take half of that, or 1 1/4. And so Robin's reasoning, she says 16 assembly lines is approximately halfway between 1 and 32. But is the corresponding number of hours also approximately halfway? So 16 lines is halfway between 1 and 32, but no, 2.5 is not halfway between 40 and 1.5. So hopefully that makes some sense, and that helped a little bit. Hope you're all doing well. Thanks for listening.